Welcome back, guys. Let's continue with the next part. Today's topic is a little bit, obviously, it is related to AWS cloud only, but it is a little bit different. And I believe you'll get a lot of new idea and a lot of new vocabulary and concept today. Okay, so let's start with the next part. Let's start with the topic. So the topic name for today is ECS cluster. So there is one hosted service in the AWS that will do something for you. What exactly this cluster will do for you, we will discuss today in detail. But the service name is ECS cluster, or I can say service is ECS. Okay, but it will help you to create a cluster for something. Okay, so what exactly they will do for you, I will explain you in a minute. But to understand this particular cluster, I have to also launch my local some of my local VM. Okay, so I can give you some vocabulary about it, right? So I have one Red Hat 8 machine in my local system to show you some demo. So guys, those who are a little bit new in this topic or technology that I'm going to discuss in a minute, you understand how the thing is going on, right? Okay, so let's start in this way. Let's start in this way. Guys, if you have an app, okay, this thing, you need OS to launch. But in this OS, you have to also configure something. Let's say you have to configure app server or web server. But sometimes it is always good to do one thing, that because we have to install the OS, we have to configure servers and put our code or website over here. And maybe this is the very common requirement that you have to do again and again. So what can we do? We do once, and from it we create a template, or maybe sometimes it's also known as image. So it depends, guys, which kind of image you created. Okay, you need that particular platform, depend upon which kind of image you have to launch it. Okay, one image, guys, what is called AMI, right? So if you have an AMI image created, so you can use EC2 as service or the platform to launch it. Okay, but only challenge is in this AMI, internally AWS launch one virtual machine, and for the virtual machine, guys, they they have some kind of real physical hardware. Okay, they have real physical hardware, and on the top of hardware they install some program or one kind of small operating system that they use the term called, and we use the term called hypervisor. Okay, depending which hypervisor they use, but according to the document, they use Zen hypervisor. Okay, and on the top of this hypervisor, we can launch multiple virtual machines that known as EC2 instances. Okay, and this virtual machine, guys, will launch from the AMI, whatever AMI you have or you have created. So this is the actual I can say the internal high level architecture of EC2 services. Right, if you talk about this one thing. And that easy region, whenever you launch any instance in EC2, mostly we use a term called shared. So these are the shared instances, or they are provided as the shared resources. Why? Because underlying hardware is one. They have one CPU connected, means one socket of CPU connected, one big RAM they have. Okay, and depend upon your requirement, as for example, you selected T2 micro, so from this one single big RAM, they cut small part, how obviously virtually, and that is then they use the word called VRAM and provide 1 GB to this RAM. But they have big CPU socket, so they virtually connect, cut the CPU in some part, it's called vCPU, and provide to this instance of 1 or 2 CPU, whatever you have provided. Okay, so typically, guys, if you go to AWS, they provide shared resources to you. Okay, how? With the help of hypervisor, and this is work in a technology called virtualization. So guys, you might know this, but otherwise I just want to again tell you. And why again it is very requirement. It is important to know. Maybe some of the things we might discuss today or maybe upcoming classes. If you think if you think you don't need a shared resources, you you can go to AWS, say I need one real physical hardware and I don't want same hardware to be shared by other instances. Okay, maybe they, because there might possibility, okay, this IP1 belongs to you and this IP2 belongs to other company, maybe. Okay, so so technically both the instances isolated as such, there's no security issue gonna come up, but maybe I don't know, we don't know when any security bug come up, so IP1 instance might somehow read the data content of the RAM and something from IP2. So there might be some flow might come up in security. Right now we don't have, but maybe. Okay, so that is reason some of the company has a compliance of security and say we don't allow share resources. Okay, I want to have one dedicated hardware belongs to me only, and on the top of hardware now it is your choice. Either you can launch one program like hypervisor. In my case, in my laptop, this program already running. This is called Oracle VirtualBox. This is also one hypervisor. And on the top of this, now you can launch two instances. One instance is maybe they are shared, but this hardware belongs to me. Okay, so this hardware is would be dedicated to me, so there is called a dedicated resource or dedicated host. Maybe I can use the word, because the system who launched the OS are also known as host. So in you can go to AWS and say which type of resources you want, shared resources or dedicated. Obviously guys, because they are giving us shared resources, that might be reason why they give us on the fly price on the fly kind of things, right? And why they are somehow very cheaper. Okay, but obviously if you ask AWS that I want a dedicated resources, obviously they charge you a lot for this. But depend guys, if you think you're going to consume entire resources, or you think that you have some security compliances issues, means you have to go for dedicated hardware and resources not used by somebody else. In this case, you have to invest the money. Maybe sometime they ask you upfront amount for 1 year, 2 year. Here, here we have to pay just on demand basis. So that is the thing, guys. This kind of resource is also known as on demand. So till date, guys, all the instance that we launched in EC2 was on demand. Means launch it, use it, and that much time they charge you. But if you go to a dedicated, because they're giving dedicated to you, so normally they charge you upfront amount of 1 year, 3 year, right? Something like this, they charge you. So this is not the main topic today. By chance, this point come in my mind, so I explained to you, but you should know. But how you can get the dedicated resources, I'll show you somehow today, right? So guys, can you hold for a second, please? But the main important topic for today is ECS cluster. Maybe ECS cluster, guys, somehow linked to this topic only. Okay, so let's come to our main topic. Okay, this is called ECS cluster. So now we have an image. Depend guys which kind of image you have created. But if you use this image to launch the instances either on the top of shared resources or maybe on dedicated resources, both are the actually finally the virtual machine. Or because both are the virtual machine, virtual machine, 1 minute. Because both are the guys virtual machine. So so what I'm saying, because both are virtual machine. So if you use an image to launch it, it takes some time, some time to launch. Okay, and that is a reason, guys. I'll let me very quickly come to topic because most of you guys might know this. So that is a reason if you have a requirement that you have an app you need a web server, app server, and OS. So we have guys some technology available in the market, okay, through which we can create image, and from this image we can launch this entire virtual machine, or entire, maybe I can use the word environment, just in a millisecond, or maybe sometime in microsecond, maybe, or maybe in second. So you guys might know this technology name. So that is obviously not virtualization technology. That technology is known as containerization technology. So containerization is a one of the technology now is very famous. I believe everybody or know this. So using this technology, right, we have certain kind of image. That image is obviously not AMI. So those images are also known as container images. Okay, but the good thing about this image is one click, one click we can launch the OS. By the here, the OS is not known as virtual machine. Here, OS is also known as container. But what we have in this container, your base OS, web server, and app server, whatever you have in this image, they will launch for you. And there's a lot of container product available in the market. One of the famous product you guys might know is Docker. So that is the reason this image is mostly known as Docker image, and this container or container is known as Docker container. Okay, so the today's topic, guys, is based on this. Obviously, today's class is not a Docker class, even though I have a detailed free class available in IIC Rise channel where I talk a lot about Docker for very basics, or mostly most of the guys might know this. Okay, so but why am I giving this vocabulary to you? Because this ECS cluster is purely based on this topic. That the prerequisite for this topic is a Docker. So just I want to sync with you so that everybody can connect what actually I'm talking about. Here, C represent container service, elastic container service. Okay, and even though there are a lot of content technology in the market nowadays, Rocket and some more technology like Cryo or Podman, something like this. But this cluster is purely based on a container, and the content product they use behind the scene is Docker. But what this product will do for you, it will create a cluster of the Docker. Okay, so anybody who by chance know Kubernetes, okay, so you can think this is the competitor of the Kubernetes. You can think in this way. Okay, you can create a Docker cluster or container cluster using a service called ECS. Okay, so logic wise, if you know Kubernetes, guys, logic wise somehow they are same, but obviously they come with some new they have their own personal architecture, and they have their own personal vocabulary. But logic wise they are same. Anybody who know, because a lot of guys here who have done Kubernetes training somehow, or maybe under me, so they know about Kubernetes. So obviously this is not Kubernetes. We are going to create a container cluster with a service called ECS. Okay, so so what is the meaning of cluster? I will explain you in a minute. But before this, I just want to show you some basic demo of the Docker, very high level demo. Okay, that is the reason I launched my local machine, because in this machine I already have installed Docker. Okay, so I can show you 2 or 3 basic commands, so you guys can connect very easily what is going on. Okay, after you guys become comfortable with these commands of the Docker, then I will move to the AWS cloud again, and and then we will start exploring a more concept about ECS services. Okay, so guys, in my case, my Docker is already installed, so I can use Docker info command to confirm. So my Docker is running. There is no challenge as such. In my case, the version of the Docker that I have right now is 18 point something. Okay, and I have a lot of images I have downloaded from somewhere. So a lot of images I already have in my laptop. Okay, so one of the images that I had created, I have uploaded somewhere, that is called Docker Hub, is this one. Okay, or maybe you can find some more images, right? So what I'm going to do, I'm going to use this image and this command called Docker run. I'm going to use this image. Okay, what this image contains base OS plus web server with some PHP web pages. And I'm going to launch with this image. Run is a command, okay, to launch the new OS that is called container. And I want to put the container in the background. I want to give my container a name. Let's say Z2, some random name I'm giving here. That's all. So one click, new container launch. So she's so quick. Okay, one click, my new container launch. Okay, and this container is running a web server on port number 80. Okay, and that's all. So one click, your OS launch, and whatever app you have in this OS, you can connect. Before this, I should know the IP address of this guy. So there's multiple way to check the IP address, but there's a command called inspect. I can go to my OS named as called Z2. It will give me the IP address of this guy. Okay, so there will be a lot of command we are going to run today, but this is the very one of the basis command of the of the Docker. Okay, so mostly most of the guys know about this command, right? But even though, let me share this command to you. But anybody who want to know much about Docker, from very basics to all the advanced, so IIC Rise channel, I have delivered almost entire training on Docker, where I explain everything over there. Okay, but why I'm discussing again this point here, because without knowing this concept, it is very impossible to understand ECS service, and that is the main topic for today. Okay. Okay, so this inspect is a command. It tell you the IP address of this system is 2. Okay, so my container running here. Okay, and if because this container is a web server, so I just curl connect to this container on IP address 2. Okay, and and I think I have put the page there, index.php. This page is there. It's my home page, and hit enter. So you can see the output come up from web server. Here I put welcome to Vimal, and there I also print the IP address of that container. So you can see the same IP come up. So everything's working good. Only challenge is the container has their own personal isolated network. So if you try to connect this container from outside computer, for example, this is my outside computer, it's Windows. I want to connect from there, it won't connect because they are running in their isolated world. Okay, something like, we have private subnet. So container has their own, or Docker has provided their own private subnet. So if you want your container to be exposed to the outside world, the way we put net internet gateway, something like this. So for this, while launching the OS, let me launch one more OS. Launching the OS, you can use option called P. P is known as padding, means like a netting. Okay, and tell anybody who come on this port number. Okay, I will connect to container on this port. Let me put port number, let's say 8081. Okay, so again, I will launch one more OS very quickly. Okay, so if means anybody come to my this base OS. So guys, I just want to give one vocabulary here. So my current setup is something like this. I have a base system running. This is called Red Hat 8. On the top of this, I launch a Docker program that is also known as Docker Engine or Container Engine. And I launch my one container here. In my case, the container name I given is Z3. Okay. But this base system where I running the Docker is also known as Docker host. And this system has IP address. In my case, the IP address of my base system is 1.4. So anybody who has connected to 1.4, okay, for example, right now Windows is connected. So for Windows, if I reach here to this IP that Windows has connected, and I ask this guy that I want to connect to the port number 8081. 8081. So if my Windows try to connect on this port, my Windows will net the traffic or forward the traffic to this particular container on port number 80. Okay, why port 80? Why this port? Because that's what I have defined here. So I defined here, just connect. So it means if I go to my Windows and type the IP address of my instance, okay, that's Windows connected, and type 8081. I finally connected or landed here. See guys, here I landed to my container, and my container, that container name IP address might be something like this. So everything's working great. Okay, so there is a meaning of padding, and there's a meaning of, maybe you can use the word for netting. So pretty simple command. Pretty simple command. This one is. But here guys, while launching the container, I have to always define this port number. But the challenge here is, let me launch one more container, and if I give the same port again, it will fail. So it's fail. Okay, why it's fail? Because here I'm giving the port number from a base OS. And my base OS, guys, port number 8081 is already used. You can run this command. Port number 8081 is already used, and you guys know two program you can't run in one single port. Okay, one single port. Okay, so it means every time when you want to launch one more container, okay, for doing betting, so outside guys can connect. Every time you have to go check if this port is free or not. If it's not free, you have to change it, then only it will run. Okay, and obviously one more small thing is your container name is also different. Okay, so there's one thing. So that is a reason Docker and the container guys has given us a facility. Facility is if you don't want to worry about which port number has been used, and you want to give a port number that is free. So there's option called -P. There's also known as publish port or expose port. So P means I automatically do a netting part for you. Just give me a container name. Okay, and automatically guys provide some random port to you. Okay, again I will connect to your internal web server of whatever port number they are running on. By some way, if you guys know about the expose keyword in Docker, so they use the expose keyword by chance here, if you know. Okay, but they give this random port. It means if I launch one more time, next time they will give you a new port. So they don't fail, next time they give you a new port. So if it means anybody come to my base system IP on this particular port, they can connect to this particular content. So that is the meaning of this capital P. Okay, so this is a facility of from the Docker by default. Okay, that will automatically give this port number. So guys, knowing this concept very important. Otherwise, it would be very harder to understand the ECS services of AWS. So this is some of the basics. Some of the basics of of the Docker. Okay, so I think guys this much basic is required, and that's all. Now let's move to the service called ECS. Okay, so what is ECS? So ECS is something like this. Right now guys, I am launched in my laptop. I have given my RAM, CPU, and hard disk. Right, this one I had given. This is called physical hardware. And on the top of this, I have given I have installed Red Hat version 8. And then on the top of this, I have installed Docker with some version. This is called Docker Engine, and manage my Docker. And on the top of this, I launch multiple OS. That's called container. So in my case, like container 1, container 2, or OS 3, I launch. So everything is managed by us. Okay, and obviously guys, all the container is using some RAM and CPU. So that again, they are shared only, but the total RAM and CPU used by container is purely depend upon how much physical RAM and hardware we have. And obviously guys, if you launch, keep on launching. If your requirement keep on coming, you will be exhausted with the resources. Okay, so for this again, you have to go launch, take one more hardware, buy one more hardware, and do the same thing again and again and again, and everything you have to manage. Okay, so what what AWS guys are saying? They are saying now you don't have to manage anything. Almost everything we will manage for you. Okay, you're looking for this hardware, we will provide for you. If you're looking for this OS, we will install for you. You're looking for the install latest updated and version of Docker and manage this guys, we will provide to you. Means entire this OS we will provide to you. How? With the help of service called EC2. So EC2 will give you RAM and CPU, and in the EC2 we have Docker Engine for Red Hat. We have some our customized AMI that we had created, tested. Okay, and that is very much optimized for container technologies for the Docker. So we provide an AMI to you. We provide all the hardware to you. You don't have to worry about. Okay, and because we provide AMI EC2 instance, now you can launch as much as EC2 instances you want. More and more you launch, more and more instances you have, more and more resources you have. And technically guys, by chance here, these guys are known as instances, or maybe you can use the word called node. This is node 1, node 2, node 3. Okay, but obviously guys, if you are launching multiple nodes, and on the top of this node you're going to launch multiple containers, obviously from some images, you need some kind of centralized management computer. That's it is also known as manager manager program or manager node, or maybe master node. Okay, so what is the duty of this master node? The duty of the master node is to manage. That's all. So they will manage this node, this manager will manage this node, so they can keep on checking that this node, how many resources we have given, Docker engine is working or not, what a container we launch working or not. If something fail, we help them to relaunch, or if entire node goes down, we notify something, or somebody, they will relaunch this node. Okay, they relaunch this node. Okay, how they relaunch, we will discuss. So if entire instance goes down, we will relaunch this node. So this manager has a lot of duty, and they take all the power of AWS cloud. Okay, but technically here, this manager is only managing the thing. Okay, and this node is actually who is providing the resources. That is the reason this node is sometimes also known as a worker node. But here all the node work together, and that is the reason it is known as cluster. But motto of this cluster is to manage the infrastructure for the content. Okay, and that is the reason, guys, this cluster is known as container cluster. Container cluster. Okay, and for this, for this, Amazon has their own customized product for this. Okay, and that's one thing in the market. There's a lot of open source product available. Like we have Mesos, Marathon, we have some product from Rancher, we have product called Kubernetes, we have product called Swarm. Okay, a lot of product is there in the market, open source or by some company, but Amazon has their own cluster product. Okay, and where Amazon say, I'm utilizing all of my infrastructure. Okay, for example, Amazon say, if I launch this node 1, okay, and if you have requirement, I will launch node 2, and my duty is to keep on monitoring this guy. By chance if entire node goes down, I will help you to relaunch the entire EC2 instance. And how is possible? Because we have so much powerful service already in the AWS. They're so powerful, they will do the thing for you. And that is called auto scaling group. You guys know we discussed this services. So the auto scaling group will tell my desire is to and I will tell the auto scaling group that keep on looking for both these instances or both this node. If one of the node goes down, again relaunch. Or because this is auto scaling group, we can add some CloudWatch alarm here and say just keep on monitoring this 2 node. If you see CPU percentage go above 80%, launch one more. Keep on launching more and more and more. So that's what we have seen. Okay, so they say we have already very much mature services. We take the help of those services to do the further thing. Okay, and even though we have one more services, because if you are launching this cluster, okay, in this cluster maybe you're looking for 2 node, and in the 2 node you want to call launch AMI, then do some configuration. So I will do everything for you. You don't have to worry about. So you just one click, because we are the managed services. So cluster that we are going to provide is pure managed. You just click and I will launch anything and everything for you. And because they launch everything automatic for you, so obviously the guys, they are using CloudFormation template behind this. That you don't have to create, but because we know about CloudFormation, so internally they have already created a CloudFormation template for you. So they use this template to launch 2 node, update auto scaling group, create the rules there, and whatever they just in one click they create everything. They create in one go because their team has created a CloudFormation template for us so that we don't have to worry much about this. Okay, so technically this is the managed container cluster only meant for container, and the container technology behind the scene they use is dog. Okay, so guys, there's the high level idea. And good thing is this manager, we don't have to worry about this manager is running behind the scene in the AWS, and they only give you a beautiful simple web UI. Just go and click, and whatever your need is, just tell them and they will do for you. So anybody who ever work on Kubernetes, there you can see a different computer running or node running. We have to configure that guy, and we have to configure those things. Right here, we don't have to worry much about. Okay, this manager is running internally, and they give some web UI and where we go and configure the thing. Okay, so there will be a lot of vocabulary, guys, but this is a very high level idea. Anybody who know other content technology like Kubernetes, they can very highly relate the things. But by chance, those who don't know about the cluster of the container, for them especially, I just have explained you this concept, what actually AWS doing with the service called EKS. Sorry, EKS, not ECS. Okay, so let me show you guys step by step how the thing works. So I'm launching AWS Cloud. So what about this? And guys says, by chance, guys, those who are doing CSA training, ECA service as such, we don't have in a program. Very highly overview we have of 5 minutes in our CSA training. But this topic, guys, is a part of your developer track. So anybody who are in the developer track, in the developer track, they in the examination they ask you multiple questions about you know ECS services. So for the CSA guys who are here only for CSA, again, take the today's class as a extra knowledge class or bonus class. But it's good to know some extra services always. So that's what we are doing here. Okay. So I'm launching. I'm going to ECS, Elastic Container Services. It is way to run the container. And here content technology is used behind the scene is Docker. Okay, so this page come up and they say, do you want to start? Or here they say, do you want to create a cluster? Obviously, yes, I want to create a cluster. They ask you, do you want to create a cluster? Obviously. Okay, I click and create a cluster. Now they are giving you multiple choices how you can create a cluster. So idea is pretty simple. They're actually talking about they're talking about that we are going to launch multiple worker node. Okay, one or two, how much node you need or instances you need. So what you want, your base OS would be Linux, or you want base OS with Windows. Like obviously on the top of this base OS, I will launch a Docker engine for you that you don't have to worry about. Just choose what you want. So do you want Linux instance or you want Windows? Okay, so obviously I will go for a Linux one. That's one thing. But guys, there is one more service, very powerful service. Maybe if we get time today, we'll definitely discuss. But maybe in upcoming class, I will definitely want to discuss this service, very powerful service that's called Fargate. Okay, that Amazon also promote a lot. Don't worry, in today or maybe upcoming class we'll discuss. But to understand Fargate, only you to first go to this concept. What we are doing today. So what if Fargate? We will discuss maybe next class. So right now I'm selecting this particular setup or the template. Okay, that I want Linux AMI behind this. Okay, that's the meaning of this line. Click next step. And now guys, here they're asking you cluster name. Let's say this is my Linux world cluster. So this is a cluster they are talking about, and now they are showing telling you and they're telling you guys, let me go back once. Go back one. Because guys, here I say I need AMI, and guys understand one thing, if you have an AMI you need EC2 services to load. Okay, why I'm emphasize this point, because you know already, but if you go Fargate, the setup would be a little different. Okay, so they say you have to use EC2 services. It means if I go to EC2, so without coming to this page, what you'll see guys, right now I have no instance running, but without coming to this page, my ECS service going to launch 1 or 2 or 3 instances here, and all the instances will be your slave node or worker node. Okay, so that's what they are going to do. Click next. So here they're talking about, let me give my cluster name. Let's say my cluster Linux World Cluster 1. Okay, now here they're asking you your provisioning model. They say you're going to launch an instance, obviously from EC2. Okay, so what would be the provisioning type of, right? So till date, guys, till date we have used and launched a instance on the EC2. Is called on demand. There's a normal standard we normally use a lot. Okay, that's called on demand. So do you want to go for on demand? This is by default the way we use per hourly charge or per minute charge. They take from you. There's no long-term commitment and there's no upfront. And if you want to have a long-term commitment, okay, you can go for a dedicated host. By chance, ECS service doesn't provide option for dedicated host, but from the EC2 portal, if you think you think you are you know sometimes we have a database services where we know data service we never migrate normally. It run for longer, 1 year 2 year, after 2 or 3 years we think about to migrate. So these are some services that we have to keep on running. And because we have to keep on running, okay, so what can we do? We can tell the AWS that this is the instance I need. Okay, and I need this instead for 2 or 3 years. And guys, if you commit those long period to AWS, they will give you a lot of discounts. And that instance, guys, is not a reserved instance. Guys, here on the left side, reserved instance. Okay, so if you go here, you can purchase your reserved instances from the AWS. And here you can go and purchase from the marketplaces and tell what your requirement, search your requirement. Okay, and here they tell you if you if you go for a 12-month of this T2 micro T3 micro type. Okay, so this is the upfront price you have to give. Okay, whatever the price model they have, but it would be very much cheaper compared to your normal price. If you go for T2 micro on demand basis, they would be higher, very high in price. But here, because you're purchasing upfront payment and also in a reserve way, okay, then they will give you a lot of discounts in this type. But by chance ECS doesn't support long-term commitment and upfront payment. Okay, and one more thing that doesn't support here is called dedicated host. So if you think you want to, because finally they are going to launch VM here. Finally, this VM is the one where we run our Docker container. This VM would be our slave. So by default, guys, they give you only shared resources. Let's go on demand. If you want, they give you a dedicated host. Okay, they won't give you. Okay, but if you have a other plan that you want dedicated host because your company compliances and you want some extra, maybe some extra performance also get in security also. So there's an option called dedicated host. If you want your own personal VM to be launched, so dedicated host you can go, okay, where you can allocate the dedicated host. Obviously, there's a dedicated. They come with their extra price because you're asking this instance of mine. If resources free, don't share to other one. I am the one who own the entire resources. So you just go and get the dedicated resources. It will be very high in price compared to on demand. Okay, so that is also, guys, you can go and use for fully dedicated. Okay, but there's by chance there's one business model or provisioning model that is known as here. They have is called hot hot request. Okay, so what I mean by this, guys, if you ever notice, whenever you launch an instance, normally there's a by default they launch on demand only, but but here in some of the page here they give you a purchase option called host spot instances. Okay, what I mean by this, guys, it is just like a you just I mean, say we have a data center, and not every time we all of our hardware is being consumed by our customer. So if you have some of the resources we have that is not used by somebody, so you can bid those resources. So guys, this is a bidding model. Okay, so for example, let's say let's say if you if you use on demand instance for T2 micro, maybe I might charge $10, for example, let's say for a war. Okay, but I have a lot of resources, maybe free that point in time. Okay, so same resources I can give you very cheap, maybe in $1, $2, that much 80, 70%, 90% discount, maybe sometime I will give to you. Give to you. Okay, so this is called spot instances. Okay, so they're very much cheaper, it is 90% cheaper from the current price. Okay, but only challenge is if you request for this spot instances, okay, there's no guarantee. There's no guarantee that that point in time Amazon data center has the resources free or not. Mostly they have, but not all guarantee. But biggest challenge is maybe they have resources free. Okay, but suddenly some extra requirement demand come up from their customers, called on demand request come up. So you know guys what they do, as such, without notifying you, they will terminate the instance or stop the instance. It means if your ongoing workload going on in an instance where you buy this, okay, so they will they have a way we can set up, they can notify also. Okay, and they give you some grace period also for 5 or 6 hour, maybe, or 1 hour maybe. Okay, but there's no guarantee. So as soon some extra demand come up, so they will get these resources back to you. Obviously they charge you that much time, the time that you use. Okay, but they want they can take their resources any point in time. That is a one challenge in spot. But spot instance is very good for colleges, universities, research perspective, or if your workload where you think if your instance goes down, doesn't matter, we have a cluster with second instance run. So like in clustering technology, this is very much useful, or maybe some kind of ETL operation or some kind of big data workload. Okay, where we have big cluster all together. Okay, so by this sports instances, we can save our money a lot, 80-90% saving we can do. And if a big data cluster, if your 10-20 computers go down, doesn't matter, right? Okay, automatic we have some master, they will manage my further resources, and they will allocate to other slaves. Okay, same like in EC2, ECS also, this is a cluster, I have 10-20 slave we launch. If one or two computer goes down, because AWS again acquire resources from you, my workload will be launched in other instance. Okay, so if you want to save your money, like anything, and you think your application is not so much critical, or you have some applications or like master system who will manage your failing part, what is called fail or part, then the best resources to take from the AWS called Spot. Okay, here they talk about the current price, and here you can bid the price. Okay, so let's say I bid for 0003. Okay, you can bid your price, and what are your bidding here? If that resources for that bid price is available, they provide this instance for you. It will launch for you. Okay, so this is what I'm bidding here, and I click next. Click next. Let's say this is the Spot OS one, just for testing, SP OT. Let's say one moment. Security group. Launch. Okay, so they say this is the invalid price for whatever I charge. So to change the price, maybe you could go above this level, or better way would be where will be there's option called spot request here. Okay, For example, this is one instance I used sometime. So I think it's now disabled. So you can request support requesters. And here they have a task. What is your requirement? It is a template, right? It's a big data requirement or something, right? So according you take the template and some more thing you can put on. So it's pretty straightforward. You just go through this, and here they give you. Okay, so here guys, they give you this this chart also, and they say if you go for T3 large, okay, you save this much amount, around 70% you save, guys, if you go for on demand. So that much that much you save. But spot price is this one. So if you want to take this instant, you have to go give a little bit higher, maybe 0.270, something like this, then we will provide. So they have minimum price. Okay, you do just, it's like a bid. So who will bid more? So example, you bid 0.3, somebody bid 0.4, and that time there is no resource available. Amazon will give priority to guy who bid more. It's something like this. Okay, so it's a pure bidding model. But just for testing purpose and researching purpose, this is the great to use. So I am saying this. First reason is I want to tell you there's multiple type. By the first, on demand, spot, reserve, dedicated. I just want to tell you because this information you should know. Sometimes they ask you in examination also the difference and use case, when to use what. Okay, something like this. Or why I'm explaining you here, because here they give you both the mode. If you think this class is for testing, okay, just go for spot and it will drop your price. This year is going to be available about 90% discount on demand price basis. Okay, so that's what you can do. But right now I'm going for on demand because this is my free tier account. Because I'm going to launch T2 micro. So that is free for some 720 hour somewhere around. So that's okay for me. But I just want to tell you this is the difference you should know. Okay. So let me use the instance type. So I'm going to use T2 micro. Okay. It means I'm going to launch one instance right now. We will launch more. So technically my cluster would be something like this. I have only one single slave or worker node. Okay. And we don't need to have to configure anything about master because this is the inbuilt facility they give to you. So master or manager computer, they provide to you with the help of their web UI. You don't have to worry about. You just tell how many slave you need. So I'm just saying I need one slave, one node, or one instance of T2 micro. So that's what I've selected. Here, guys, they give you AMI ID. So I said this, they already give you pre-configured AMI. You have to select one. So obviously I'm going for 2, means version 2. That's the latest one. I'm choosing one. What the hard disk size you want to use, and because finally they're going to launch one AWS instance. So if you want to log in there just for checking something, okay, technically they create everything for you, but let's go and log in to see something what they have done. Okay, so I'm attaching a private key pair so I can log in and test what is going on. Okay, what is going on. I just want to tell you one more small thing, guys. Here, you know what? Behind the scene, this is the master or manager. Is called ECS manager. Okay, and this would be my worker node or instance. Okay, so the duty of manager node is to keep on monitoring the worker node. Before this, worker node has to first register with the master. And for this, guys, ECS has their own personal program called agent. So in this worker node, they will launch an agent, and the agent duty is to connect to the master. So master can manage the worker node. Okay, so guys, when I launch this worker node, you will see automatically one agent they launch behind this. So anybody who know Kubernetes, so in the Kubernetes, the agent name is called kubelet. So here it's not kubelet because there's a different cluster altogether. Here the agent name is called ECS agent. They will configure and launch, and they automatically register also to the master node. Everything is they manage, but you don't have to worry anything about it. Okay. So this part is done. Networking, obviously, guys, because this is the EC2 instance they are going to launch. So you just select which VPC you want to use. So I'm going to use my default VPC. Which subnet you want to use, because this is the one single instance. Let's go for subnet. one, but maybe I have to launch some more worker node in the future. So let me select multiple subnet. And why multiple subnet? Because I have some plan for load balancer also. So if we have multiple subnet, multiple instance will launch in multiple subnet, so we can have proper high availability setup. So I'm selecting all the 3 subnet that is available in Mumbai right now in my default VPC. I'm going to attach a public IP. Okay, if you want, always public IP to what? To my worker node, so that I can log in and see what is going on just for testing purpose. Okay, and my security group, I'm going to create a new security group where I'm allowing all or some particular port because my plan is to do SSH, so I'm allowing port number. Okay, so I can do SSH and see what is going on there. IAM role, guys, behind the scene, guys, they create one IAM role for you. Idea is simple, guys. ECS is a service who are going to connect to EC2. Okay, so these two services connected, so they have to create one IAM role for you. Okay, in my case, I already have, but in your case, you don't have to select, automatic they will connect, create for you. What is a role? You guys know. So there's no extra thing we have to discuss here. Okay, so this IAM role they create. One more, guys, new things they added in recently in AWS cloud, a concept called CloudWatch Container Insight. Okay, so what I mean by this, if I go to CloudWatch, you guys know now the use of CloudWatch. So in the CloudWatch, there's a multiple different sub services. You know, CloudWatch Alarm, you know, event, you know, logs, you know, metrics. We had discussed in our last classes. But if you go down, there's one more service recently they added, is called Container Insight. Okay, what this service will do, this service has a capability, okay, to monitor your container infrastructure. Even though they have some capability also, they can go also inside the worker node to see there how many container running, how much, which container using which, how much resources, means RAM and CPU or some more thing. And nowadays, guys, if you guys know microservices, microservices, so mainly, guys, nowadays microservice purely managed on the top of container technology only. Okay, so if a big complex microservices setup, so they have very great service to see the performance and monitor everything about those resources. Okay, so this service is purely meant and optimized for the monitoring by checking the performance for the container world. Okay, but do you want your cluster will send the information that's called metrics to CloudWatch Container Insight? Okay, what CPU, all the things that you guys know, there's called that's called what this called you know, metrics by some other information you want to send to CloudWatch. If yes, enable it. Now this cluster will go and send your container information or the container host information or all the metrics, and especially the metrics I'm talking about, not the log, to the container inside the service. So you don't have to worry, they will auto pick, and after you pick, you can see they will create monitoring pages here that will monitor your cluster. Okay, I'll show you how it look like. Okay, let me create, that's all. So now, guys, they are creating a cluster, and you guys know, because they are doing everything automatically, 99.9% in AWS, if they do anything and everything automatically, behind the scene they run CloudFormation template. So these guys has already created a CloudFormation template for us, and with the help of CloudFormation template, they are doing everything for us. So technically, what happened, if I try to explain you what they have done behind the scene. So they launch one entire instances, obviously where in EC2, it means if I go to my EC2 page, last time I had 0 instance. If I click refresh, you can see one come up. If I click here, you guys, this instance right now launched, and this instance is not launched by me, it is launched by ECS service. They also give the name. Because at the time of launching, I attest and say a public IP I need. So we click here, this will come with the public IP. Okay, but if you see the AMI and all the things, whatever I selected that time, those things is being selected, or those AMI and everything is being selected. This is the private key I selected, everything come up. But here this is launched by ECS service, obviously with the help of cloud formation template. Okay, one more thing guys they have done, we'll talk a little bit more about this. Okay, because right now it's very common, this is a cluster. Right now in this cluster we have one single node, but it's very common because we say cluster, it means we're going to launch 2 node, 3 node, 4 node. All right, so and and I also want, if one of the node goes down, let's say my desire is 4. You know what is desire, we already discussed, right? If desire 4, so I want some service to keep on checking. If one of those thing goes down, they automatically relaunch for us. It's called auto scaling group. Okay, so guys, this instance is not launched directly. Okay, this instance is launched with the help of auto scaling group. How can I show you? Okay, if I go to my EC2 page, if you go down, you guys know here we have option called auto scaling group. If you guys click here, you see guys, this auto scaling page automatically. And guys, even though you can see the tag name also, so this auto scaling group is launched, is created by ECS service. And here if you see guys, only one instance. Okay, and if you go in the detail, you can see the desire is 1. Why desire 1? Because we tell the EC2 that time that I need only one instance. So because they are decided 1, so here they actually internally they contact to this service and ask the service to launch 1. And maximum also 1. Okay, so that's what their launch behind this. Okay, so maybe some more services they use, but these are the 2 main things we need to know right now. Okay, now this has been launched, my cluster is up and ready. So if I go to my cluster, view cluster, so my cluster page look like this, and they say guys, now this page is the master page or the manager page. So you know, I was talking about master, so they give you this web UI, and you don't have to have any master, and they don't give any master. They behind the scene, the master is they give you by this web app. Web app. Okay, and but this master, by this web app or master, we can see how many nodes we have. So right now it is very clear here. If you go down, how many EC2 instances we have one instance running is active. Okay, here also we can see one instance is active. So that is the cluster is also active. Again, they show you some more detailed instance ID. You will land it there only, which data center is launched and how much how much memory they have. And this instance obviously guys is what is one where you are running with Docker engine. So they also mention here which version of the Docker, this is one of the latest updated version of the Docker they are running there. Okay, so everything they posted. Good thing is because I launched this behind the scenes, because they are running EC2 instances, and I know the ID of the EC2 instance. So I can go to this page. So this instance they're running, and because I know the IP address, I also know the private key. So what I can do, I can do putty on this instance, and what you will see, I will lend it to the slave node of this guy. And what you will see there, you will see there, everything is configured for us. So anybody who have ever configured Docker and all the things, you will see here, you don't have to worry about, everything has been configured for us. Okay, so let me show you. Let me log in with root account. And right now, if you see, run the command called docker info. So you can see, guys, this is been configured. Okay, so this has been configured, and right now they're using this version of Docker. Okay, so you don't have to worry about this point. And second interesting thing is, I told you guys in this instance, they are running agent. Technically, this agent also, guys, they're running with the container. Okay, so if I run the docker ps command, you can see this is the agent running, and Amazon has their own personal image where they put the agent. Okay, so 4 minutes ago they launched this agent, and technically because they for the Docker container they need image. So first of all, guys, they download the images for us. Okay, and from this image, they launch this agent. Anybody who know a little bit about Docker or Dockerfile, behind the scenes guys, they're running this command or entry point. And this is the program who has a capability to connect to the master. Or because this guy connect to master, that is a reason, that is a reason from this page, I can see one guy is connected. Because my agent is true connected. You can see here it's correct. Okay, so till here our cluster is ready. Okay, but if you need more instance, we can have more instance. How? I will show you with some of the practical. If you need say second node, third node, we'll see. But right now guys, our cluster is ready to you. But why I launch the cluster? Because I want to launch the container. Now yeah, it is your choice. You can manually go and launch the container here the way I did. I show you my local computer. But again, guys, this is not one single node. We have lots of node, right? So it is not good practice to go manually to the worker node and launch launch your own launch the container manually. You can launch here because you know the Docker command, but it's not good practice to actually go and launch. So let's master manage everything. Right, so now we as such don't require to go here. Let me disconnect or minimize. Master will do everything for you. We don't have to worry about. For this, what to do? Obviously, you tell the master what I want. So you tell the master that I have one image in my Docker hub, either you created or somebody else created. For example, if you go to hub.docker.com, this is the way one of the public website where we keep a lot of images. Okay, so in my case, there are a lot of images. Like for example, one of the images I have created, I have uploaded this one. Okay, or maybe there's public images from different tools. You can go and check. Okay, so I want my ECS cluster, ECS cluster, and I want please go to Docker Hub public website. And normally, guys, Docker is a very standard thing. So almost all the tool in the world or cluster technology in the world, they by default always go to Docker only. Even though if you guys go to Kubernetes also, they will always go to by default. You can change, but by default they go to Docker Hub only. So ask this guy go to Docker Hub, and we have some image here. For example, by this name, go and download. Go and download. Obviously, where you run, and obviously where you're going to run in our worker node that I have one. So download this image. After download this image, run it. Obviously, after the run, what you will see one new container come up. But I don't want to do it manually. I want master will do and manage for us. But for this, you have to tell your requirement. Okay, so tell your requirement which image to download, right? Or maybe your requirement maybe after you say just download this image, and after this image launch a container. How many containers you want? You want one container, you want two container for the same images. Okay, so you can tell that requirement also. Okay, so let's say I want 3 container of the same way. Means 3 container launch, means 3 services launch, or it means 3 in my case this image is about web server, 3 web server launch. Why? Because maybe this is the web server, or my client going to connect to this web server. Okay, so maybe we have a requirement that we have a huge client. So I want my first client to connect to this guy, second client connect to this guy, third client connect to this container. So that is the reason I will say here that my desire is 4. Or because it's 4, that is called replica here. You can tell how many replica you need is called 4. Okay, but if you want to go for one more than one, so for this between client and this guy, we have to put some container. Put some load balancers. Okay, so here the load balancer, okay, through which client will go to actual container is normally known as service here, SVC. So guys, this is the same terminology that you use in anybody who know Kubernetes, the same terminology we use here also. Okay, this is one thing. So technically, you have to tell what you want to do. So technically here is called task. You tell your task definition. Okay, you tell your task definition. So anybody who know Kubernetes, in the Kubernetes, it is known as deployment. right? But here it is known as task. So you have to create a task, and task is the one who define which image to use, how many content to use, and XYZ. So anybody know Kubernetes? Is logically they're same, but here the term is task. Okay, so that's what we have to do here. Okay, so right now if you see in your current cluster, this is my cluster. Okay, and I don't have any task running. Okay, now task only one instance running, but this instance is the OS. On the top of this OS, we are going to launch multiple containers. That's the only thing we have. So I'm going to my cluster. Okay, and if you see guys here, there's an option called task here, and you see guys, there's no task we have arrived. And so one thing, task is the one who going to launch a container or set up the container requirement for us, what we need. So we have to create a task. Either you can click on run new task here, or there's a separate option in the top. Look at task definition. Click. Here you can create your own task where you can define what exactly you want. Okay, click here. Again, guys, what if I forget, we'll discuss. But right now, the way I launch my cluster with the help of EC2. So I'm selecting EC2 here in the task page. Okay, 1 minute. Let me access my document. There's one place, please let me connect to power also. Okay. Where is the page? Yeah. Click next. Now here, they're asking you a task name. They say my task web some name. Okay, and because I launched my setup in EC2 instance, not in Fargate. What is Fargate? We'll discuss. So by default, this name come up. Now this is some kind of role they will automatically create for you whenever we need. Okay, we don't require a network mode. Anybody who know about networking or overlay network, something like this, so they will set up this thing for you, so you don't have to worry about. I don't want to discuss right now as a again, it will be a long topic, but those networking that you normally sometimes you set manually or by yourself or somehow, or by some CNI drivers, if you know, they have their own, so they will configure for you. Okay, here guys, IAM role, because these guys had to connect to some CloudWatch services to publish the log, so they will create IAM role for you. Again, you don't have to worry about this. Guys, here they're talking about task memory. What I mean by this, they say we have the worker node. Okay, and this worker node, let's say you have 1 GB RAM, or let's say you have 4 CPU. Okay, so my task, I'm going to launch a container, maybe 1 container or 2 container or 3 container, right? So 1 container launch, maybe you have a replica of 3 replicas, so 3 container launch from 1 single image, mean 3 OS we launch. But in totality, okay, how much RAM or CPU we want to provide to this guy. Okay, so that is our task memory. Okay, so by chance, guys, if you go back, let me use EC2, so ECS. Okay, so by chance, guys, right now I have 1 single node. Okay, one one single node, and there I have only around 1 GB RAM. So obviously you can't go more than this. So what can I do here? I can say, let's go and use where is, let's 400 MB. That's the maximum RAM we can use. Okay, so this is MIB inside. Okay, and by chance here I have only 1 CPU. It's called 1024. A lot of guys has no idea why they put 1024, but if you guys anytime go to detail about performance tuning, there we discuss a concept called CPU shares. Okay, so technically CPU guys always give you a time. So if you say if you 1 CPU, So normally, especially Linux system, guys, we divide the total time of one CPU into 1024 times. This is called 1 unit. So if you have some process running, you can share your time of CPU. How? Let's say you want to share your time in 1/4. You can say your process, I'm sharing you 256. 256 is what 1/4 of this guy. So this process can use this much time or this much share of my CPU. So there's a long concept, but I think very high level I explained to you. So technically that's what they represent here. So in this system, you might have 10 CPU, 100 CPU, doesn't matter, but this is a total CPU share we have. How many share you want to give to this container or this star? That's what they're talking about. How much CPU share you want to give? So let me give 256 means 1/4 CPU share I am giving to this task. Now in this task, you want to launch 1 container, 2 container, 3 container, that would be different thing. Guys, don't think task is a pod. Anybody know pod? It's not a multi-pod. Okay, task means it is just we are defining. Okay, we are defining like a deployment, means we're defining how many container we need, and totally this much resource we need, but every container is independent. But why you launch more, I explained to you, because of load balancing. Okay, so that is a meaning of this particular. Okay, and now this is the important point here, container definition, because finally you're going to launch a container, so you define here which image to use and XYZ. Okay, and if I click here, okay, guys, this page is exactly like this concept. In my local computer, I explained this concept. So when you launch a container, you have to define which image to use, which port number this image server is running, and which port number you want to expose, what container name you want to give. So same thing you have to tell here. And that is it, guys. I first explained this concept to you, so I can fill this out here. So here I can tell my image name. So I have my image in the Docker Hub. So let me take my image name. From here, you can use any image, whatever field you want to launch here. So I'm picking my image name, and guys, by default, they put download from Docker Hub only, so you don't have to worry about. Okay, just give your container name. Let's say this is my web container 1. Okay, and guys, because this is one container I want to launch, so here you can decide what is the maximum memory you want to give to one container. Okay, so there's a hard limit. So let's say I want to give 128 MB RAM. So technically it's work like this. So total RAM you can give, I decided 400. Okay, but one container can't use more than 128. Okay, so if you launch 4 containers, you can launch, but all one container can't use 128, or maybe 100, 100, 100, 100 they can use like this. Okay, so this is per container limit, and task is total container we're going to launch, maybe 2 or 3 as a replica in the future. So there's a meaning of this limit. Okay, so what? Now, right here the port mapping. Okay, this is exactly same concept over here. So if you want, your container will connect from outside the world. So technically, because my base system where I am launch my worker node, I have the public IP, and this system is also known Docker host. And because they have public IP, so anybody who come to the public IP worker node, and I want, if somebody come on port number 8081, they can connect to my container. Whatever container port IP would be. Same concept that I use locally. Okay, so that's what they're asking. So anybody come to my host port here is my node port on port number 80, 81, or 80, whatever you want port, and then connect to my port 80. I know this is image created by me, and I know in this image we have web server running on port number 80. So that is the reason I have to put the port that is running there. Okay, so that's what. Okay, so that's the guys only configuration we can do. But anybody who know lots of things about Docker, Docker, almost everything you can set up here. So it'll just show you, you can do health check commands, your shell scripting you can write here. Okay, you can do CPU limit, entry point, right, command, environmental variables. Okay, okay, network settings, almost everything. If you guys know about Docker, the storage thing, volumes, so everything you can about security, privilege, access, right, resource limit, you limits, everything you can set here. So obviously there's no meaning to go in this point, but if you know Docker, you can set up everything. But this is a minimum requirement we have to set up here. Let me add. Okay, so that's what we have done. So I think this is the main thing we do. Very interesting thing is now these guys also support service mesh. If you know guys, service mesh is so powerful topic. I'm planning to have come up with one great workshop on it. I'm trying on microservice and service mesh of Envoy or maybe STO. I'm trying to have the time, but this is also supported right now. I'm enabling this, otherwise things become more complex, but let's not enable this. Okay, and otherwise as such we don't have to do anything else here. And finally, create the task. So guys, task has been created. Okay, they're showing you the final summary. This is the task they have created. Right? They only created a task. They haven't launched the task. Okay, task created. So if I click here, this task has been active and created. Okay, but it is not yet run. Okay, and because they are not yet run, so if I go to my worker node again, there is no new container come up with our name what I decided. Okay, this is the only task, means this planning part and definition part we have done. So anybody who know Kubernetes, you know, there we create a YAML file as a definition. So it's like this, we create a YAML file, and that's all. Now we have to run it. But before I run it right now, if you click here, they put all the information in JSON file by chance. So guys, this is the information we put. You know, for example, port mapping, we put this host port, this protocol container port, and whatever we have configured here, this is the image I'm going to use. So that's what guys they put here. Okay, so so this is just a definition they create. Now how to run this? For this, what we have to do, if you want to run this task, we have to do something like this. Okay, so I'll tell this information, this is called definition, and I'll say go and run. But idea one thing guys, this definition is going to launch a OS that is called container. Okay, but you have to decide how many container you want to launch, 1 or 2 or 3. But it's very common guys, at least multiple container we normally launch. That easy reason guys, whenever my client connect, whenever my final client connect, right, I want my client traffic would be load balance. So what normally we want to do, we always want to create a container behind a load balancer. Here the load balancer known as service, SVC or service. Okay, either you want to connect one container or maybe more container in the future, or scale in or scale out. Okay, having load balancer is always helpful. And guys, this is not the AWS load balancer. It is one of the internal part of the cluster. So all the cluster container cluster technology, they have a service concept, right? Where through which okay, if you have more than 1 or 2 container, and if you come to your host, they are the one who balance the traffic. Okay, so this is not the external load balancer. What I mean by this, you know, AWS, we have a load balancer called ELB or ALB. So they are not. Okay, this is the internal concept of your clustering technology. Okay, so technically, if you want to launch the container, service is the one who will help you to launch it. So you have to create a service and provide this definition of service, and say service, use this file, use this setup, right? And this will help you to launch the container by some image and some of the things, whatever we configure. Okay, and for this, I have to go to my cluster again. There's no tab here left side, the guys for service, because this is part of your cluster. Right, this is cluster guy you see here. Okay, we don't have, there's option guys to create a service. Okay, in this cluster, we don't have any task yet, because tasks we created separately, because same task you can use your multiple cluster also. Maybe some other cluster also want to use same kind of setup. So create a task that's like your code created in JSON or some other language. And if you want to use multiple time in multiple clusters, you can use it. But how you can run? You run with the help of service. Okay, and here I have to first create a service. Create. Now here they ask you how you want to launch. Right now, it's not Fargate, we haven't discussed. My setup is running directly on EC2 instances. Okay. Now you want to launch a container. What is your definition here? So guys, they auto pick up because we only one. Okay, and version come up because guys, this task is exactly like your code, and because your task is exactly like your code, it means if you change anything in this task, anything they ask, they auto create a new version. Here, version they created. 1:1 is version, version 2, version 3. So the guy automatically create a versioning for you. Okay, that's what guys asking here. Okay, which version you want to use? Right now we have only one version. Okay, which cluster you want to launch? So I'm going to launch in this cluster where I am right now. What is your service name? Let's say my SVC1 is my service. Okay, how many number of tasks you want to run? Means how many container technique they were asking you to launch. So let's say 1 or maybe 5. So 5 container they launch for you. Okay, and that is guys the type is called replica. Okay, so if you want to launch more than one, then you do use a type of replica. But there's some concept guys here. There's some kind of use case. I don't want to elaborate more, but just think in this way. Okay, there's some kind of requirement come up. We have one worker node, 2 physical EC2 instance, 3rd EC2 instance. So sometimes we have some use case come up where you have to run one container here, one container here, one container here. All 3 containers come from same image, but per node only one container. Why? Because one of the reason maybe some agent node. Okay, you want to monitor something in your local computer. Okay, so this is the one of the use case where I want to launch multiple replica of my container, but replica automatically detect how many node we have. If 100 node, 100 container to launch per node, one container. Okay, so guys, this is concept is called daemon. So anybody who know Kubernetes, so there I talk about daemon set. It is same concept. Okay, that's what they're talking about here. Daemon set. But here automatically, you don't have to tell. So they auto detect if you have 10 worker node, 10 they launch. If they one worker node, one they launch. But if you go to replica, it means you decide even though one worker node, 100 worker node doesn't matter. I need total 5 containers. That's all. And this is the example where you want to launch 5 database server or 5 web server, app server. So that's the idea. So anybody who knows Kubernetes, it is like a daemon set. Anybody who knows Kubernetes is like a replica set. So you can think in this way if you know Kubernetes. Okay, but doesn't matter, guys. If you don't know Kubernetes, I'm explaining also every point over here. But right now, just for some example, I am using only one container. But we can scale it, guys. Afterwards, I'll show you how. Okay, so minimum healthy percent per 0, so I can they launch very quickly. I don't want to check any health to make it faster. Okay, so that's not so much critical here. And here, guys, how you want to deploy the container? I'm using rolling updates. And guys, what is rolling update? I think in my last week Beanstalk, I explained you some of the concept of rolling update there. But anybody who know Kubernetes also, so same concept of deployment you have, strategy, same concept we have. So I'm not explaining further. You guys know this. But they have Blue Guru also. So anybody who are purely in CS, so developer track. So in the developer track, we have some more services. We take the separate class on this. One service called Code Deploy. It is more about CI/CD. Okay, so I will explain you about Code Deploy in the further classes. That by this service you have blue green deployment. So I will explain you this service in the future classes. But they have rolling update. Okay, so this is by default strategy in a very simple line. If you want to understand this guy again, so right now I'm using one image to launch a container. Image to launch a container, but anything change in the image in the future, I again relaunch the container. If I relaunch the container, my client will disconnect. So what rolling update will do? They launch first container, new container, send all the older traffic somehow to the new container, then they terminate the old one. Okay, very simplest way I want to explain you in this way. That is the meaning of rolling update. So any new image come up with new web server changes or website changes. So we don't have access any kind of downtime. Okay, so there's a concept of rolling update. Okay, and that's all. Nothing special here. Next step. Okay, now everything good. What is load balancing here? I'll take one example of load balancing, guys. This is the external load balancer. It's called ELB. So we have a way to connect this cluster with external load balancer also. Okay, you know, ALB, ELB, NLB, CLB. Okay, why we need, I'll take one example on this if you want, but right now I'm skipping this point. I'm going for without this. Okay, and service mass we don't require right now. Okay, this auto scaling setup, you want to add some extra thing in auto scaling group. You know, CloudWatch, I told you guys, they keep on monitoring the system. If CPU goes about this, launch one more auto scaling. So I don't need right now. Okay, that this is a final review, and let me create. That's all. Now, if you click on view service, the service is now active. Okay, now very quickly, let me go to my cluster. Now you can see, guys, service active, and service is the one who launched the task. So if you go in the task, they have launched the task. And guys, because you know the speed of container, guys, they're super fast. So as soon as I launch, my container automatic start. So guys, see here, right? My container is running. So this is my master page or management portal. This is the one who are monitoring that in your cluster, one task is running in EC2 instances. Okay, means one container is running, and they also given the container ID also. Okay, but I can, because I know some Docker command, so we can go to our worker node because we already log in here. Okay, and what you will notice, guys, here, without coming to this worker node, you see one instance automatic come up. See here, this instance automatic come up. Again, this is exactly same way come up, right? 81 port to 8080. This is the exact the one that I use in my local computer. But here in my local computer, I use manually, but this guy is managed and launched by master or by ECS service. Okay. And because this issue instance has a public IP, so click on this container, they tell me the public IP of it. Okay. And this public IP, guys, it would be same of this instance. So if I show you the instance, so it is same public IP. So they figure out the public IP or base system. Okay. So it means anybody come to this public IP on the port number, which one, whatever I put there in my task, there is, I think, 8080 or 8081. So anybody come to this, you know, guys, the port number, as I can see somewhere, they written. So now anybody come to this IP address, on port number 80, 81, or whatever I put there, they can connect. Right now, it's not connecting. And when guys, you see this kind of screen, there's somebody waiting, mostly the chances is firewall. Okay. And why the firewall? Because guys, you know, when this instance launch, okay, because technically I'm kind of this instance on EC2. And this instance is launched with a security group. At that time, guys, I only enable, you know, today initially I enable only SSH. So if port number 8081 is not enabled, so what I do, I will go and create one more rule, or just to make it very simple, I'm just allowing all traffic. So I'm just allowing all the traffic to make it straightforward. Save. Okay. And now if you hit enter, now this page comes. So guys, see here, I'm hitting to the IP address of my host computer. Okay, but finally I landed to the container, or maybe I can see use the word task, but technically no container only, and you can see I landed there. So working great. Okay, so it's the same output, guys, but in my laptop I manually manage. Okay, I have to provide my resources, but here everything resources management purely done by cloud, and that is actually main use of cloud. Cloud is a pure management system, right? And they are managing for you, and everything they are managing technically setting up for you, right? So it has been working great. Okay, and let me go to my cluster again. Okay, and the guys cloud was also monitoring this guy because I enabled container inside. So these guys are the one who monitoring. So you can go to CloudWatch page. They will give you more insight about the content. Okay, we'll see in a minute. So this is my cluster, and so because here I say in my service say my desire is one, so they are launching only one. Let's say you some more traffic come up and you want to launch one more container. So simple, go to the service and you say, because my right now my replica desire is one, only one container running. Okay, but if I update this guy and say I want my desire to be two, that's all. Okay, so it means two tasks. Technically here it means two container they launch for you. Anything extra? No. Next step, and next step, and update. Okay, so service guys again updated, and technically now because your desire is uh, let me go to my cluster again. You say a desire two, so they will launch two. Right now they are only running one. Let me go to my cluster. So desire two, so they will launch two, but they are not running two. But let me also check manually. Okay, does they launch two? No, they don't launch. Why? Okay, so this is the same idea what I was talking about. Okay, so if I launch same thing in my local computer also, right? So if you have one single host, if I launch a container, okay, if I launch a container with port number 82 that is already given to somebody, it failed. What say you are going to launch a one new container, that's okay, but this port is already given to some other container, or because we have one single host. So one single host, same port number, I can't go give to second container. Same thing happened behind the scene over here. Over here. So we can have one single instance here. And in this instance, guys, I already occupied one port number, that is 8081. Okay. Already acquired. So if you're asking to launch two container, and because both are running from the same task, and this task say this container also going to use same port 8081, but 8081 is not free because we have one single instance. So it failed. So intent is failed, and that is reason you can't see here, or that is reason you can also can't see here. Okay. So for this, what we have to do, one of the possibility here, I can launch one more EC2 instance. Okay, so one container will launch in first instance, second container will launch in second instance. So what I'm going to do, guys, here, I'm going to scale my cluster. So this node is my first node. I'm going to launch one more node. Okay, how? So for this, in the in some a little bit older portal of AWS, here they give the options to scale, but nowadays they remove. I believe they remove this option here to scale. But internally, I told you guys already, this each instance is managed by auto scaling, right? So I can go directly to auto scaling group, right? I will show you there, and this auto scaling group. Okay, and there because we have decided to have my desire is one, so I can go here and change my desire, let's say two. Okay, because I say my desire two, I have to also increase maximum also two, because if you don't allow more than one, how they fulfill the desire. Okay, so there's one thing I changed in auto scaling group, because behind the scene they are managed by auto scaling group only. Okay, and now because I tell my auto scaling group I launched two, so behind the scene guys they launch two instances for you. Okay, because they launch two instances for you. So if you go to your instances, you can see automatic two instances launched for us. Okay, only one is visible because second one they are launching in a minute. In a minute they will come up, and after they come up, automatic they run the agent, and as soon as the agent come up, okay, they automatically register with ECS. And after register, you will see the name come up here. Okay, because now there are two instances. Sorry, it come here. And now after this, you have two instances. Okay, both is an independent instance. So my task says you need 8081 port number, or my service say you need two containers. So by default, guys, Automate Master will decide launch one of the container in one worker node and launch second container in other worker. And why this challenge we are facing here? Because in my task, we had decided that I need port 8081 only. It's fixed. So same port I can't give in two container in the same worker node, right? So that because of that challenge, we are facing this issue. And that is a reason, that is a reason, guys, it is good practice. Like if I show you my local computer also, don't fix your port number. Okay. Use option called hypercapable kind of concept. Okay. So we can do this concept also. They automatically randomly keep on choosing the port number. So in one computer, we can use launch thousands of container without any kind of issues. Like that is I explained this concept already to you. So ECS also have capability to support this option. How? I will show you. But before this, let me show you that these two instances come up. So now see guys, there's two instances running. And because both instances come up, so my service is waiting. As soon as you come up, you can see two is running. Now I have a two container running. Okay, two is running. And if I click here, second run on this IP address. So both running, both the different IP address because they're two different instances. And if obviously if I hit enter, hit enter on port number 8081. Right, this is the IP of that container. Okay, so or whatever the IP that of that other one has, welcome. Okay, so this one you can do, but it's not good approach because it's not good practice that per container one instance, right? Otherwise unwanted a lot of resources going to waste. So I have one instance, and and on the top of this instance I want to launch multiple containers. Okay, so how to do this? But challenge would be, guys, right now, because this port number we fixed, uh, uh, but if they launch automatically with some random port, so this problem will solve in one instance. I can launch multiple container, but challenge would be how you come to know which port number they use. One of the way would be I can go to all of my worker node to check what port number they consume, but it's not good practice. So I want some kind of dynamic setup. First of all, I want my one computer launch hundreds of container, obviously with a random port number. But without knowing that port number, okay, I will able to connect to those containers. Okay, so it's a little bit complex, but what exactly I meant to say, I don't want to explain you right now. But this something like this we have to do. And guys, here the role of dynamic load balancer concept come up. So it's a bigger topic. So in my next class, I will explain you how we can create external dynamic load balancer of AWS. You know, ALB, you know. So ALB has a facility of dynamic uh, load balancing on some random ports. Okay. So I will explain guys this concept in next class again. Don't worry. Okay. Then I'll show you how to set up. It's so simple to set up. You don't have to worry about uh, all the complexity is done by AWS guy. You just click somewhere and they will do your setup. So this is one of the topic we'll discuss next class. And after this, I explain you Fargate. After having those knowledge, understand the Fargate won't be a big deal. Okay. And there's some small services for container we will talk about in the last class. Sorry, in the next class. So, so guys, a lot of things we have discussed today. I suggest at least till here you go and launch a container, launch multiple nodes, launch multiple things. And very quickly, I want to check your Cloud Watch also. So in the Cloud Watch, if you go to performance monitoring, okay, and here, because my cluster is ECS cluster, and your cluster name is MyC2, you can see guys, all this graph come. Okay, so container inside giving you the total utilization, memory, network, how many instance, 2 instance we launch, how many tasks we launch, how many services running. Okay, so this is a specialized service. They know the metrics about the containers. Okay, for ECS, and we have one more cluster which is called EKS, is the Kubernetes cluster. So they can monitor all the container related metrics. Okay, so there's a portal they have, so they will provide you those information to you. Okay, so that's all guys for today. Lots of information I'll post here, explain to you with practical. Okay, uh, uh, so that's all for today. Define EKS guy. EKS is, somebody asked me, EKS guy is a managed Kubernetes services. So if you ever work on Kubernetes, so what you guys use do in Kubernetes, they will do management. Entire Kubernetes cluster they manage for you. Okay. Guys, when somebody post here about CSA and CSA developer syllabus, and just one thing, guys, CSA or developer course are different. They're two different training. If you see the content, okay. Anybody who by chance only register in CSA, so from our side, we are giving a lot of developer training content as a free and bonus. Okay, so it's good for CSA guy, but some developer guys might be put here. So why you charge extra? Okay, so why guys, whatever you charge for, you are getting those content, right? So you should be happy that we are helping some other one also. Okay, so I think I'm very clear on talking about. So don't compare why somebody getting extra. Just focus on you. Whatever you guys giving your time and your money, you are getting that content. Okay, so that's the way I think we have to think on of. So, but yeah, a lot of content of developer I'm delivering here. Like I want everybody should learn. But yeah, there's some content come up that will be exclusive class, guys. Don't worry. Of developer like code pipeline and all the things. So that is not at all the part of CSA. So there's no meaning to discuss those content on the CSA training. What the use case of or use case to use Docker versus normal issue service? Hemant, actually, I don't understand what exactly you're talking about. What the use case to use Docker or normal EC2 service alone? Actually, I don't understand what exactly Hemant you're asking, but I think you're talking about Docker versus or container versus virtualization. So obviously, this is a long discussion and topic. So if you go to my Docker classes, it's free available in IIC Rise channel. I actually discuss a lot of thing about it. Because there I discuss about container versus virtualization. But whatever guys I discuss about virtualization, it is it is same for EC2, because EC2 service is also virtualization service. For my side, a very happy birthday, as in Kia, what you write that you said today is your birthday, so a lot of wishes from my side. Where is master present? Master, guys, is a internal program, actually, technical say. So they say if we manage your master, you don't worry, but we just give a portal to you. So just you go there and manage the thing. Okay, so that's all. So master is a managed, pure managed service. You can think master is a serverless here. You can think in this way also. Only master I'm talking about is serverless. Yes, Aman, you can do somehow. You are saying you can pick the ECS agent from here. You can put the ECS agent in your local computers and make your local computer also a slave. But if AWS allows you to do, okay, because right now behind the scene, the instance they launched, they have a role attached. Okay, so they have security. So each instance have a role attached that have a capability to connect ECS master. Okay, so in local computer you can't attach role actually. So maybe some issue of security might come up. Okay, but you can try. You can log in local computer, AWS config command with some root power and then try. It's a good point, Aman, you write here. Just try it, and in local computer, log in with AWS configure command with some extra power and privileges or policy you guys know, and then try to do it. It might work. Just try it. Yes, seriously, you can use Lambda function with Fargate services. So there's some use cases where we can integrate Lambda with EC2 Fargate. So answer is, can we connect? Yes, answer is yes, you can. Yes, seriously, you can go command line also. Like guys, right now I configure the task 4 or 5 or 2 here. I use web UI, but same thing, command line is also available. You can go to AWS ECS command line. There also you can go and change the task. Okay, but I don't want to go command line again and again, because I given you the almost all the concept how to use command line. So the same approach you can use and do the same thing from the command line. So what is right meaning of daemon? Actually, this concept is technically its full name is called daemon set. Okay, so if you Amol, if you have some certain requirement where you want, if I had 100 worker node, in all the worker node, I need one container or one particular image to be launched. Only one, max and minimum one, right? Uh, so this thing we can control only with daemon. Okay, and why we need this? Because there might be requirement that I have some monitoring tool or agent and I want, if 100 node or 200 node or 5 node, as soon as the node scale or down, right, automatically my this agent launch there, that's called daemon, and they start monitoring. So this is one of the use case we can we can think of for the daemon. Okay, why don't we use EKS? I haven't said Saswant we don't have to use EKS. The topic is only ECS. I never said we don't use EKS. EKS is so powerful service and very much a recommended service, right? No, Weber, it looked like ECS and EKS same service. As such, the main role is same, but you can think EKS is a managed services and they use Kubernetes as a product behind the scene. And if you know the power of Kubernetes, everything you can achieve there. ECS is again managed services, but this cluster and product is also developed by AWS. So whatever AWS community ECS come up with a feature, that much features there. So you can think ECS or EKS are the competitor. Okay, maybe there are two services for AWS, but one service Amazon created, one service they managing, but product is created by open source. That's called Kubernetes. So Weber, we can think in this way. So Uh, can you expect any program in Dynatrace? Yeah, actually, Dinesh, I was thinking about, I get a lot of query on these kind of topic. Maybe Dynatrace or Splunk or New Relic. One of the program I am planning, not as such, but I am planning soon to come up with, right? So because having knowledge on this level of tool is very important for in organizing. So either Dynatrace or New Relic or maybe Splunk or maybe App Dynamics. Some tool, all the tools have some little differences. Some of the tools is very different, like App Dynamics is APM tool, but I'll try to at least take one of the topic somehow. Yes, Sagar also service mass also still I'm planning to do. But yes, okay, next week we have a one powerful workshop on NoSQL. Let's go MongoDB. Highly recommended. Lots of nowadays we need a lot this kind of tool. So if anyone want to join MongoDB, they can join in the workshop. No, Aditya, a ramped deployment is not same as a rolling update. Okay, rolling update is different. Ramped deployment is different. ECS, I don't think so. They have ramped deployment. You have to go to Kubernetes. They have a ramped and rolling update both. So ramped deployment is different. Yes, Aswant, we can do entire OpenShift setup on AWS manually. And nowadays they have a service also. Let's go OpenShift as a service. Is recently launched. So like EKS for Kubernetes, OpenShift they have a service also. So you can use that service also to set up OpenShift. Yes, actually, Cryo, they are is not actually Cryo is mostly used in Kubernetes world. So Cryo is a specialized tool developed by Kubernetes community to have a better support in Kubernetes. But in other container cluster, wherever you see container cluster, you never, as such, you never see Cryo. But wherever you see Kubernetes cluster, maybe OpenShift is again an example of Kubernetes cluster, you will see Cryo there. Okay. Yes, you can compare Vishal, Zen hypervisor, other. There are a lot of other hypervisor like KVM we have, VMware, Hyper-V, tons of hypervisor we have. Here, these guys are using Zen. Yes, yes, Radhika, task is just a definition, means it's like you can think like a code, and this is the when this is the one who decide what to launch. Okay, so if you have something to launch, one single image to launch from that image to container, so the planning or that plan is called task definition. Okay, like in Kubernetes, we launch one YAML file, and from the one YAML file you can launch multiple times. Okay, so that YAML file you can think is a definition. Yes, Sobit, I am also very proud of you guys. Very proud of you. So that's all, guys. Lots of again discussion we have done today, and See you guys tomorrow. Not tomorrow, next class. We'll with some more things. We'll add more information in next class of Fargate and some more things. Bye. See you. Take care.